In the previous lessons, we learned how to interpret chemical formulas in order to count how many atoms of each element that make up a molecules. For example, we have 2CaNO3, 2 calcium nitrate. And in that lesson, we learned about the coefficient. And the coefficient indicates how many of the entire molecules. So in this case, we have 2 of calcium nitrate. Then we also learn about the subscript. Now, the subscript, first of all, it tells you how many atoms. Well, for example, in this case, that 3 right there indicate there are 3 of oxygen. But when we have a subscript outside a parenthesis, it tells you there are 2 of the whole entire polyatomic ions. So we have 2 of NO3. But when we have calcium, it doesn't have a subscript there. We just know it is 1. Well, in this lesson, we are going to look at multiple substances and count the number of atoms from those substances. Let's look at the first example. We have 2 carbon dioxide plus 5 water and energy. Well, energy is not considered as matter. If we were to count the number of atoms for each element, carbon, so notice how carbon is right here, and it doesn't have a subscript, so we know it must be 1. And there are 2 of carbon, so it must be 2. Well, for oxygen, look at this. Oxygen over here, we have 2, right? But 2 times 2 give you what? 4. So 2 times 2 give you 4 oxygen. But over here, we also have oxygen right here, and 1 times 5 give you 5. And 5 plus 4 give you a total of 9 oxygen. Then we have hydrogen. Well, in this case, 2 times 5 give us 10. So 2 times 5 give us 10 hydrogen. And that's pretty much it in terms of counting how many atoms for each element from multiple substances. You just add them. Look at this. That's addition, so just add them, that's all. Let's try another problem. Here we have this substance and oxygen gas. So what we have here is this. Look at carbon. Well, carbon again, there's no subscript, so 1 times 3 gives you 3. The 3's come from there. And then for hydrogen, here we have 2 times 3. Well, 2 times 3 give us what? 2 times 3 give us 6. And then what do we have over here? We have oxygen. Well, right here, 1 times 3, that gives us 3 oxygen. Here, 2 times 5. Well, 2 times 5 gives us 10. What is 3 plus 10? That gives us a total of 13. And that's pretty easy, isn't it? Now, let's try the last one where we have more complicated substances. Here we have aluminum nitrate plus potassium nitrate. Well, for aluminum, what do we have for aluminum? In this case, 1 times 2 can give us 2. But for nitrate, which has oxygen and nitrogen, well, look at nitrogen, 3 times, right? Because there are 3 nitrate here. And times 2, well, 3 times 2 give us what? In this case, 6 nitrogen. But wait a minute. What about over here? Over here, we also have 1 more, so 6 plus 1 give us a total of 7 nitrogen. Then for oxygen, very straightforward. Here we have 3 of the nitrate, so 3 times 3 give us 9. But that 9 is being multiplied by 2. So if I were to look at oxygen, that 9 is being multiplied by 2, give us 18. Well, over here we also have 3 more, so we have 18 plus 3 give us a total of 21. And that is how you count the number of atoms for each element. It doesn't matter how many substances you have. You just add them all together by interpreting one chemical formula at a time.